In previous presentation, we are going to discuss what is the introduction of smart grid and what are the definition related to smart grid. So, what are the key challenges are for smart grid? So, you have studied all these things in the PowerPoint presentation. Now, it is a continuation of what we studied in the PowerPoint one presentation one. So, in this, we mainly discuss what does a smart grid do. That means what is the functions or what are the duties of smart grid we are going to discuss in this PowerPoint presentation. So the first topic is what are the functions of smart grid. So coming to the functions of smart grid, the duties of the smart grid, efficient transmission of electricity from generating stations to load centers, and quicker restoration of electricity after power disturbances. So whenever the disturbances occur, it is immediately to be solved and reduce the operations and management and reduce the peak demand, which will also help lower electricity rate, increase the integration of large-scale renewable energy system, better integration of customer-owner power generation system, including RES, and also improved security. These are the duties of smart grid. Coming to smart grid functions, the integrated system of smart grid has two scopes. One scope is transmission monitoring, and reliability, and includes the following capabilities: real-time monitoring of grid conditions, improved automatic diagnosis of grid disturbances, automated response to grid failure. At a minimum, the ability of signal homeowners and business that power is expensive supply. The next level of implementation would allow the utility to automatically reduce the consumer's electricity consumption. The smart grid would automatically detect failures. A smart grid would make it easier to install distributed generation. So coming to comparison between existing and smart grid, so it is electrochemical, it is digital. In this one-way communication, in this two-way communication, it is a centralized generation, it is a DC distribution. In this limited sensors, in this sensors throughout is manual monitoring, it is self-monitoring, in manual distortion, it is a self-healing. So coming to today's grid and smart grid. So active consumer participation is more in the smart grid. So generation and storage options available in the smart grid. So new products with level technology is going to use in the smart grid, and provision of power quality is more in compared to ordinary grid. So they are the new technologies for smart grid. Wide area monitoring, production and control, VAM, PAC, large scale renewable energy generation, adaptive protection, advanced automation, energy storage, advanced metering infrastructure, energy management system, distributed generations. These are the new technologies. Energy storage systems and new generation technology, wave energy, waste to energy, solid state transformers, microgrids and AC grids, V2G technologies, hybrid concepts, advanced metering infrastructure, charging station, cyber security, and wide area management. These are the new technologies. Coming to benefits, is improve the operation efficiency that is related to optimizing network design, improve asset and resource utilization, it increases the energy efficiency, it give better customer satisfaction. The main agenda is to maintain green, reduce the emission via DSM and peak solving. So coming to key figures, the Indian population is 130 crores and total area is 3.28 million tons. The energy is mainly generated by oil, coal, nuclear power plant, hydropower plant. So consumption is in terawatts. This is the consumption, and electricity generation is 326. So this is the Indian power scenario. The majority of generation is done by the coal, and after that renewable sources, that is solar mainly. Hydroelectric power there is a 14% generation. Then nuclear just 0.837, and diesel we have very slow generation. So this is the installed capacity in gigawatts past 10 years. So year to year there is a increment in the photovoltaic systems and wind generation system, and also biomass, and also hydroelectric power plants. So continuously the improvement of generation is increasing from past 10 years. So these are statistics how energy is supplying, what are the generating sources available. So wind, solar, biomass, biogas, smaller and others. So up to April, this is the data which will available in the 2016. So these are the RESs which is integrated with the normal power generation. So Indian Smart Grid Minister of Power with inputs from Indian Smart Grid Forum is asset this. The main vision is transform the Indian power sector into a secure, adaptive, sustainable, digitally enabled ecosystem that provides reliable and control quality of energy for all active participation of consumers. So in smart grid standards, facility between low voltage direct current. LVDC forum is selected by 48 volts. These indoor applications. BIS published new smartest standard that is IS 16444. Another standard is IS 15959. So standards for the smart meters are IS 16444 and data protocol IS 15959. No standard required for communications. Communication technology BS standard smart meter is IS 644, single phase electric meters, three phase electric meters, smart meters. So standardization within the field of electronics and information technology. The scope of limited 10 power system control and associate come to prepare Indian standards relating to power system control equipment. So for perfection of planning, operation and maintenance of power systems, it has 7 panels that is P1, P2, P3. P1 means interpolarability. The panel formulated standard and power system communications. P2 is related to security and P3 related to common information model. It is maintain the standards between common information model for information exchange. So it is IS 16366. It includes part 1, part 2, part 3. So part 4 is a phasor measurement unit. This is a panel formulating standard. And P5 is a DMS distribution management system. P6 is digital architecture framework. And P7 is advanced metering infrastructure. So it is a panel formulating a draft on AMI. So the IS is 16444. Also electrotechnical development under BIS formula standards related to smart grids. So standardization means the field of electrical power generation, transmission, distribution, equipment, including insulating materials, process control instruments, and primary and secondary batteries, and also measuring the values. So challenges is mainly self-healing action to be maintained. So security in reliability, renewable energy sources integration, that is solar integration, power flow optimization, power system stability. So energy storage system for cost. In this we have to consider what are the key challenges is cost, complexity, non-flexibility. So continuous motivation is needed. So that means data anticipating, data corruption, sharing of data. So consumer awareness must be created. So coming to reliability, grid automation will improve the reliability, but it is a key challenge for smart grid and grid reconfiguration. And also to improve the power quality, we need to identify the disturbance occurrence and self-healing out to maintain. So thank you.